The National Electrical Code does not contain a specific provision that mandates an allowable wire load to be 80% of the rated capacity under conditions tied to operation time. However, UL Standard 758, titled Standard for Safety for Appliance Wiring Materials, does address current carrying capacity limitations. Specifically, UL 758 stipulates that the allowable current carrying capacity of a conductor should be limited to 80% of its rated capacity when the conductor is operated continuously at or above a temperature of 60 degrees Celsius, which is equivalent to 140 degrees Fahrenheit. It is crucial to distinguish between the National Electrical Code and UL standards. The NEC is a widely adopted standard for safe electrical installation, providing comprehensive guidelines for electrical systems in buildings and structures. It focuses on protecting people and property from electrical hazards. UL standards, on the other hand, are primarily concerned with the safety testing and certification of products. UL 758 specifically addresses appliance wiring materials, ensuring that these materials meet stringent safety requirements. The 80% dirting factor in UL 758 is applied to conductors operating continuously at elevated temperatures to prevent overheating and potential fire hazards. Continuous operation in this context refers to operation for 3 hours or more. When conductors are subjected to high temperatures for extended periods, their insulation can degrade, leading to reduced current carrying capacity and increased risk of failure. By limiting the current to 80% of the rated capacity, UL 758 aims to mitigate these risks and ensure the safe and reliable operation of appliances. It is important to note that the specific requirements and dirting factors for conductors can vary depending on the application, the type of conductor, and the environmental conditions. The NEC provides detailed tables and guidelines for determining the allowable ampacity of conductors under various conditions. These tables take into account factors such as conductor size, insulation type, ambient temperature, and the number of conductors in a raceway or cable. For example, NEC Table 310.15b16 provides ampacity ratings for various types of insulated conductors based on their size and temperature rating. This table is used to determine the maximum current that a conductor can safely carry under specific conditions. In addition to the ampacity ratings in Table 310.15b16, the NEC also includes adjustment and correction factors that must be applied to account for factors such as ambient temperature and the number of conductors in a raceway or cable. For example, if a conductor is installed in an ambient temperature higher than 30 degrees Celsius, a correction factor must be applied to reduce the allowable ampacity. Similarly, if multiple conductors are installed in a raceway or cable, an adjustment factor must be applied to account for the increased heat generated by the conductors. These adjustment and correction factors are essential for ensuring that conductors are not overloaded and that they operate within their safe temperature limits. The NEC also includes requirements for overcurrent protection, which is designed to protect conductors from damage caused by excessive current. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds the conductor's ampacity rating. The size of the overcurrent protection device must be selected to protect the conductor from overload while also allowing for normal operating current. The NEC specifies the maximum size of overcurrent protection devices based on the conductor's ampacity rating. For example, a 14 American wire gauge copper conductor with type TW insulation has an ampacity of 15 amps, according to NEC Table 310.15b16. Therefore, the maximum size of overcurrent protection device that can be used to protect this conductor is 15 amps. It is important to note that the NEC is a minimum safety standard and that more stringent requirements may be necessary in certain applications. For example, in critical applications such as hospitals and data centers, it may be necessary to use conductors with higher temperature ratings or to provide additional cooling to ensure reliable operation. In addition to the NEC and UL standards, other industry standards and best practices may also apply to the selection and installation of conductors. These standards may provide additional guidance on topics such as conductor sizing, dirting, and overcurrent protection. It is essential to consult all applicable standards and regulations to ensure that electrical systems are designed and installed safely and reliably. When selecting conductors for a specific application, it is important to consider factors such as the operating voltage, the load current, the ambient temperature, and the environmental conditions. Conductors must be sized appropriately to carry the load current without exceeding their ampacity rating. The insulation type must be selected to withstand the operating voltage and the environmental conditions. In corrosive environments, conductors with special corrosion-resistant insulation may be required. The NEC provides detailed guidance on the selection and installation of conductors for various applications. It is important to follow these guidelines carefully to ensure that electrical systems are safe and reliable. Here's a summary of key considerations. Firstly, determine the allowable ampacity of the conductor based on its size, insulation type, and temperature rating, consulting NEC Table 310.15b16. Secondly, apply any necessary adjustment and correction factors for ambient temperature and the number of conductors in a raceway or cable. Thirdly, select an overcurrent protection device that is sized appropriately to protect the conductor from overload, following NEC guidelines. Fourthly, consider any additional industry standards or best practices that may apply to the specific application. Fifthly, ensure that conductors are installed in accordance with the NEC and all other applicable regulations. Remember that proper conductor selection and installation are critical for ensuring the safety and reliability of electrical systems. Failure to follow these guidelines can result in overheating, insulation degradation, and potential fire hazards. By adhering to the NEC, UL standards, and other relevant industry practices, electrical professionals can help to protect people and property from electrical hazards. The NEC also covers different wiring methods. These wiring methods describe how conductors are physically installed and protected. Examples include rigid metal conduit, electrical metallic tubing, non-metallic conduit, cable trays, and direct burial cables. Each wiring method has specific requirements for installation, support, and protection of conductors. The NEC outlines these requirements in detail, ensuring that wiring systems are mechanically sound and electrically safe. One important aspect of wiring methods is proper grounding. Grounding provides a low impedance path for fault currents to return to the source, allowing overcurrent protection devices to quickly trip and energize the circuit. The NEC specifies grounding requirements for different types of electrical systems and equipment. These requirements include the size and type of grounding conductors, the methods for connecting grounding conductors to equipment, and the requirements for grounding electrodes. Proper grounding is essential for preventing electrical shock hazards and minimizing the risk of fire. Another important aspect of wiring methods is protection against physical damage. Conductors must be protected from physical damage that could compromise their insulation or mechanical integrity. The NEC specifies requirements for protecting conductors in areas where they are subject to physical damage, such as in exposed locations or where they are subject to mechanical stress. These requirements may include the use of conduit, raceways, or other protective measures. In addition to the NEC, other standards and regulations may also apply to electrical installations. These standards may include local building codes, fire codes, and industry-specific standards. It is essential to consult all applicable standards and regulations to ensure that electrical installations are safe and compliant. The NEC is updated every 3 years to reflect changes in technology and industry practices. It is important to stay up to date with the latest edition of the NEC to ensure that electrical installations are in compliance with the current requirements. Continuing education and training are essential for electrical professionals to stay informed about the latest changes and best practices. By continuously learning and improving their knowledge and skills, electrical professionals can help to ensure the safety and reliability of electrical systems. The National Electrical Code is a comprehensive document that covers a wide range of topics related to electrical safety. It is an essential resource for electrical professionals, building inspectors, and anyone involved in the design, installation, or maintenance of electrical systems. By following the NEC guidelines, we can help to protect people and property from electrical hazards. Always consult with a qualified electrical professional for any electrical work. Electrical work can be dangerous and should only be performed by those with the proper training and experience. Do not attempt to perform electrical work unless you are qualified to do so. The NEC is not a substitute for professional judgment. It is important to use good engineering practices and to consider the specific circumstances of each installation when designing and installing electrical systems. The NEC provides a framework for safe electrical installations, but it is ultimately the responsibility of the electrical professional to ensure that the installation is safe and compliant. In summary, while the NEC doesn't explicitly mandate an 80% rating based on operational time, UL 758 does for appliance wiring at elevated temperatures. Understanding both standards is critical for safe and compliant electrical practices. Always refer to the latest editions of these documents and consult with qualified professionals for specific applications.